Good morning to all. Today we are going to discuss about pulse amplitude modulation and demodulation. Basically pulse modulation techniques are three types: PAM, PWM, PPM. That is pulse amplitude modulation, pulse width modulation, pulse position modulation. So first of all we will see what is pulse amplitude modulation. What is the difference between the pulse amplitude modulation and amplitude modulation? Means in pulse amplitude modulation the carrier is clock, whereas in amplitude modulation the carrier is sine wave. That is the difference between pulse amplitude modulation and amplitude modulation. So now we will see how to do the experiment. Here we have AF signal generator, synchronous clock generator, modulator and demodulator. First I will explain how to give the connections to this. First of all we need to check whether this AF signal generator is coming or not. We need to check AF output from here. Give the positive terminal here and negative terminal here. Next we need to check whether the synchronous clock generator is coming or not. So here we need to take the clock output. Then give this AF input here. This output is given as input here. Then this synchronous clock output is given as input here. Then we need to check for the sampled output or flat top output. Here we are going to get the sampling pulses and the amplitude is same as the message signal, and here we are going to get the flat top output. Next we need to give output of this sampled output as input to the demodulator. Then we are going to get the demodulator output. This demodulation output should be same as the AF signal generator. So now we will check one by one whether the signals are coming or not. See, just I have given the input to this one, sorry, positive to this one and negative to this one. You can take the ground here or here. Why? Because we have the common ground. So you can take anywhere in this kit as ground. Now I have connected this one. I am going to switch on this kit. So how to connect this adapter, that is also very important. Here we have the notch like this. We need to connect the adapter and you need to check whether this is 18 volts adapter or 8 volts adapter. Then switch on the kit. See here we are getting only line. If we increase the amplitude and frequency, we need to check whether the signal is coming or not. So sorry, I forgot to switch on this one. So now it is on. We got the signal. See, sometimes this amplitude is in low level. At that time we will not get the any signal. So if we increase the amplitude slightly, then we will get the signal perfectly. And this is the amplitude and this is the frequency knob. See, by varying the frequency knob, the frequency is also going to adjust. Minimum frequency, maximum frequency, and here I am going to vary the amplitude also. Amplitude is 0. Now the amplitude level is maximum. So this is the AF signal, which is also called as modulating. We will see the clock. Just I am removing this connection and I am going to keep in this. See, we are getting the clock also. Okay, that is the clock. So here which time period you need to note down means this time period you need to note down. Why? Because T on, T off are same. Here T on is maximum, T off is minimum. That's why take this one as the clock time period and this is the amplitude. From here to here, that is the clock time period, and here to here, that is the amplitude of the clock. After checking the input signals, AF signal and clock signal, we need to give these two signals as input to the modulator. So before going to that, switch off the kit. Just I am going to give the output of AF as input. Next I am going to give clock signal as input. I think this connection is not correct. I can check the probe. So now the connections are made for the modulator. Okay, now we need to check for the output. See here, these are the positive is connected here and negative is connected here. Now I am going to switch on the kit. See, we are getting the output, but for one cycle how many samples we need to guard. So for that purpose we need to adjust this one. See, for one cycle how many samples you are going to get, that you have to note down in this experiment. So for one cycle, so from where to where it will be one cycle means we need to compare this with the message signal, that is AF signal. So just I have connected channel 2 of the CRO to the AF signal, positive here and negative is connected here. Next I can go for channel 2. So this is the channel 2. See here, for one cycle how many samples we are going to get. Actually how many samples we are getting, that is enough to note down for this experiment. Why? Because this sample is the, what is the time period of this sample is equal to the time period of the T on, clock pulse we have na. So this pulse on time period of the clock and off time period means we will not get any pulse. Okay. So here for one cycle how many samples we got, that is enough to note down. Why? Because the on clock time period is equals to the pulse duration. Whenever we have the off pulse we do not get the any pulse. So likewise we will get the PAM. See, this is the modulating signal or AF signal or message signal, and this is the clock signal. And here see the width of this on time period, then only we are going to get the PAM output. So pulse amplitude, whatever may be the amplitude of the message signal, that we are going to get the output at that pulse time period. See here, according to the theory we got 8 pulses. According to practical how many pulses we got, that we need to note down. So this is about the pulse amplitude modulation. Now we will see we are going to get the demodulation or not. This is pulse or sample and hold output or sampled output. Now we will see flat top output. See the difference between the flat top. This is the flat top output. Top is flat shape. Previously it is like a sample. Now it is flat. That is the difference between these two. Okay. Now this sampled signal has to be given as input to this demodulator. I am going to switch off this kit. So just connected from here to here. Previous connections should be as it is. Now we need to check for the output at demodulator. See, I am not going to modify any connections. Inputs are as it is. In channel 2 we have the modulating signal. Previously we have compared now in channel 1 we need to get the demodulator. Now I am going to switch on the kit. See, we will get same amplitude, same time period, but this phase shift will be there. Why? Because from modulator onwards we are going to get the demodulation. So this phase shift will be there in any demodulation. So we can avoid that one, and we need to check whether the time period is matched or not, amplitude is matched or not for the demodulation signal, that we need to know down. Okay, this is about the pulse amplitude modulation and demodulation.